want to go through because all the talks were recorded, so I know I should go back and watch them all. So. And we should be live as people are joining in. Say hello in the chat. It's always really fun to see where people are watching from too. So if at a bare minimum you want to put in where you're watching from or why you're interested in auto research, which is the discussion point today, or anything else, put in the chat. I know we start the stream a minute or two early, so it's live while people are joining in. So me and John were both at the AI Agent Summit in Seattle this week, and we were just kind of catching up on that. So it was pretty fun. I was saying there's recording of all the talks there. I didn't make it to the talks because I was on the exposition floor at a table there most of the time. So we're just saying lots of cool stuff happening. Seattle area, I don't know, has a pretty cool ecosystem. I like it, obviously. I'm biased.
I encourage people to find they were recorded, so you can go on YouTube and find them. But the talks were great, and you could definitely see a different quality bar as folks from Google got up and spoke about what they're were working on, and then the last keynote from the closing keynote from Meta. You could just see this. Oh my gosh, they're really into this. So.
Were you in the hot takes part? Because that's what I was also curious if there were any good hot takes.
Yeah. There was a good theme in there, and just in terms of sandboxing MCPs, and
cool.
How it was phrased a way. I don't remember the guy's name, but he kind of made it sound like don't use MCP at all, but I think it was just more around the architecture around it has to be well thought of and planned. So
interesting, yeah. I mean, it would be fun to go. It's fun hearing those hot takes, and it's a hot take. He knows that, right? So and there's also people say MCP is dead, which I don't believe, but oftentimes when something new comes out, and then maybe people are overhyping a technology or overusing it in certain ways, and maybe it's not good for every use case. I have to go watch the recording. So yeah, if anyone else wants to watch it, I think it was the MLOps community, which people might be familiar with. They hosted the AI Agent Summit this week in Seattle, and that's what we were just talking about if you're just joining in. So there's a recording of it on YouTube as well that I'm gonna have to go watch later. Someone said hello from San Diego. And someone said anything fun or any fun thing happened this weekend in Seattle. I don't have a lot of weekend plans. I'm not sure what's going on this weekend. This week had the Agent Summit, which was fun. And I ended up going to a couple other Python meetups this week, which was fun too. All right. So we're at 12. Welcome, everyone. I'm sure people will keep rolling in. If this is your first time at the kind of build and learn weekly Friday series, just to kind of set the scene. I don't know a good word. I've been calling this like a semi-casual event where every week so far we've had a topic for discussion. So the past ones were only several in. We started with talking about MCP, and then the goal is that you also build a project. So I know not everyone does this, or you won't be able to do it every week potentially if you don't have time for it. But there is a topic for the week, and that might be a specific tool, a specific model, or more of a general topic in the AI area. And then the goal, at least for me, and I think a lot of people attending, is that you want to spend 30 minutes to an hour or more, depending if you have more time, building or researching that tool. So maybe you read about it, come here, and then we kind of all discuss it live. And then if you've built something, you're also welcome to show it as a demo. So John is joining. He's been building awesome demos every week around the topic, which is really exciting. And this week, the topic is auto research. If people are already familiar with auto research, let us know in the chat. It's Andrej Karpathy's concept that he tweeted about. I'll actually share his direct GitHub repo. We'll open this up in a little bit too and go through it. But he also tweeted about it a couple times. I think this is this might be the original tweet, if you want to check it out. And the idea, if you look at his GitHub, is that you're basically, actually I have a little well, I'll hit the ideas here is that you give a AI agent a small but real training setup. In this case, they're like training a large language model kind of from scratch or doing the pre-training phase. It's a smaller version of his nano chat here. And the idea is that you don't really touch any of the Python code like maybe you normally do if you're working with like Cloud Code, programming stuff. All you do is kind of write out instructions in this program markdown, which again, we'll show this in action here. And then the markdown files are used to provide context to AI. And then it autonomously does kind of like a research step. In this case, by default, the way he has it set up is every 5 minutes, it goes in and it changes the code file. So you actually give it a train.py file. And this is really the only file, the way it's set up by default in here is the only file it's changing. So it changes code in here or hyperparameters. And then it runs a training step for 5 minutes, sees if there's an improvement on an evaluation metric, and then it'll try something else. And then so you can go through a whole bunch of different research steps of changing like a LM architecture, changing hyperparameters, which is really cool. Yeah, so the original one goes through setup. I'm going to go through, and if you go to the AI build and learn repo, everything is kind of tracked in here for every week as well. So if you want to look at the code, links for anything like that that I share, register for upcoming events, you can click in here. And so this week is AutoResearch. Next week is a model-specific one, which is going to be playing around with Gemma 4. And then people have been requesting doing something around vector stores for RAG and agent context, and then as well as doing graph databases for like graph RAG and graph context. And I'm going to post those later. I might have something that comes up next week that makes me push these out a little bit. That's why I haven't scheduled other ones yet. But the idea here too is to have interesting topics that you think are interesting as a community, and then we can go through and discuss them every week, or hopefully build on them every week. So opening up right now too, what should be another upcoming topic that we should add into the list? Let us know what you want to play around with next, or watch us play around with and talk about next. So I'm going to click into the AutoResearch here, and I have a little graph that I made that kind of illustrates how it works. So again, this links to the original repo, which I encourage you to go check it out. That has pretty good setup instructions too, if you want to set it up and actually get this running on your computer. So the idea is, again, like we mentioned, you have an AI agent train, in this case, a LM or build an LM from scratch kind of. I think John has a different part of the demo. But the idea is you have something like a train.py or a model.py, and then you're building or editing the architecture for it. This could be anything. So you could change this out in your actual use case to be any type of model or really any type of project building. And then the idea is, again, trains for 5 minutes, checks whether the validation bits per bytes, I think is what this stands for, is a metric for kind of compression of measuring if it can predict the next token efficiently. And if it's improved, then you've made a good change to the architecture and you keep that change. And if it got bad, then you would discard that change and you kind of keep a log of all these. And we'll see what that looks like here in a minute. But it's kind of a little diagram. So you have your agent that you start with. Again, by default, they use Claude code, but you can use like Codex or anything like that as well. And then I actually, for my project, I ended up using Gemma 4. So I could run this overnight without burning all my tokens. And I wanted to get a local setup for that. So I'll show you what the results look like with Gemma 4 instead of Claude. And then you give it some instructions from that program.md that we mentioned. And then it's going to edit this train.py. It's going to train on a 5-minute budget, how it's set up here. You might want to change this if you have a smaller GPU. 5 minutes might not be enough. So you might want to up to 10 minutes. Again, this is like flexible for you. And then it's going to look at that evaluation metric and then see if it improved or not, and then either keep that change or revert it, and then basically do this over and over again. And it's going to repeat until it's stopped, or you give it an iteration cycle. So by default, again, if you follow the Karpathy set of instructions, they use Claude, and then you run it with skip permissions. So like it won't ask permissions, it just runs, which again, be careful wherever you're running that, if that's something you want to do on that computer or not. Oh, and we had someone else join in the stream. Oh, also, I'll mention, welcome up, Jay. If you want to join the stream, message me on LinkedIn if you want to come in. Oh, and someone had a good point. I think I was saying training the LM. You're not training the LM. I think I used that word. It's refining the harness the LM is confined by. So you could do this for training, which I've done something similar with a training piece, and changing the way that's built. Hey Jay, I know you've messed around with AutoResearch quite a bit.
Yeah, I was on vacation last week or two, but prior to that, when Karpathy first posted it, I did some experimentation with Claude initially, and then I was trying out some local models as well, and just basically seeing how well it translated to other types of use cases, like doing an RL feedback loop rather than specifically training an LLM. But yeah, it's a good idea, just generally, as far as a looping iteration system.
Yeah, and I think so you can do the training part, like someone called out. It's changing the harnesses defined by, but I think I could be wrong. In John's project, I think actually does training on stories. So like he has two projects inside, and Jay, I think you've run them both, so you can correct me if I'm wrong. One is editing kind of the architecture of the small LM, and the other one I think is fine tuning it on like stories or something like that.
Yeah, it's tiny stories, which I think is a curated set of children's stories. It's just a smaller data set.
Yeah. And I think that's what John did. So we'll see that in action here. But yeah, the loop here, like oh, sorry, John, I saw you unmute if you want to mention something.
Oh, just confirming. Yeah, I use tiny stories.
The loop here is pretty simple. So this is nothing really super crazy, but is like packaged up in a good way to kind of get started. And right, I mean, like I've done a similar thing with programming and stuff like that, and having longer running agents where I say, hey, go like run this thing until it works, or improve values, or improve some sort of score. But this just ends up being kind of a packaged, a good packaged up way where I guess like almost the more unique thing is like the entry point is just this program.md in the original repo that you provide like the instructions in. And then it looks at this. This is like a read-only thing. You can read all these instructions here. And then it just runs that loop and just edits, in this case, that train.py instead of multiple files. So pretty similar if you've been using like Claude or anything like that too. You can. Oh yeah, and someone said volume is too high from Jay. It is somewhat loud. I don't know how to adjust that on my end. Right, and then so the thing I did that I kind of added in here, if you want to check this out, oops, sorry, in the build and learn one, I'll share the exact AutoResearch here. Was I had a local one. So someone said local LM is where the money's at. Yeah, I didn't want to burn all my tokens overnight. I mean, I guess if it's running one, well, no, it runs multiple things like every 5 minutes. So I didn't want to burn all my Claude tokens. So I have a DGX right now. So I wanted to use that GPU and run it overnight on Gemma 4 and see how Gemma 4 would do. I don't have a full overnight comparison on Claude, so I don't have like a side-by-side comparison yet. But you can check out the code that I did here, which basically I just added this driver.py, which allows you to swap out a local LLM call in there, and it has like timing and stuff in there, so it's not built into Claude. Also have some functions, so I can run this in Flyte or Union, which is something I want to experiment more later with doing like parallel experiments, and then being able to fan out compute for that I think would be interesting. And then I have this local agent that actually calls I'm serving on a llama. And they have a workflow, which is like a Flyte workflow. So when I'm running it, actually gets rendered in this like terminal user interface, which is kind of nice. And then has like a report that gets generated, which we'll look at here in a second to see how this actually did. I think those are the main things I really added here, but I just really wanted to, like, I can swap this out from Gemma 4 to Quen, whatever I want to do. I used Gemma 4 last night. And then if I look at the report, I need to fix this chart for how long it is now. But this is kind of like, you'll see similar reports from the official Karpathy repo as well, where this is like the starting point for that value. And then these green dots are when it did a change and kept it. And you can see this value is decreasing, and it actually continues to decrease still. It's still running right now. It's on iteration 70 something. And then I can hover over these, see all the changes that it actually did to the code or hyperparameters. And then I can also just scroll down in here. So you'll also see discard, keep. It'll go through sometimes, in this case with Gemma 4, quite a few that didn't actually help. And then it will find one that works and decreases that score, and then keeps and keeps. And it actually started getting a little bit better again later on in the cycles, which is cool. And I think, I mean, all the code is there if you want to hop in and check it out. If there's anything you want me to go over, I can. Otherwise, I think, I don't know, John, do you want to share what you were working on, and we can circle back to any of these other topics?
Sure. I'll screen share.
Let me catch up on chat too. So it said if they put their old fine-tuning file in a for loop, it'll become AutoResearch. Yeah, I mean, it's pretty similar. Actually, it's funny. I mean, this is a cool idea, and it's like packaged up nicely. But yeah, there's not anything super crazy. Like, there's so much hype around AutoResearch when it came out that I thought there was going to be a little bit more to it. And again, not trying to, I guess, like, knock on it. Like, it's a cool idea. But it's pretty similar to a lot of other like agentic loops either I've used or have seen. Yeah, John's screen. Someone said, can they run this on a MacBook? I think Jay's run it on a MacBook, and you should be able to as long as you have compute for it. So if you have one of the larger M chips or something, it should be fine.
Yeah, my volume might still be loud. I'm trying to figure out what's going on with that, but I have read it on my Mac. There was a version of AutoResearch that was published, and I think it's linked in the README at the bottom of the original one, that is specifically compatible for MLX. So someone immediately made a version that was compatible with Mac's or Mac Metal hardware.
I turned your mic volume down, and that sounds good to me now.
Okay.
Like from StreamYard. So. Let me know if I think it works for everyone, but let me know if anyone's still, if it sounds like Jay's screaming in your ear, you can let me know. But yeah, I know there's a version that will work on Mac. Like Jay said, it's linked in the repo. And then by default, I think the Karpathy one works on H100 or something. So I actually had to do some work to get it to run on the Grace Blackwell 10. And actually, I didn't point it out. I should have. One of the cool things is when I ran the first experiment with Claude, I can show this after John's demo. What it did first was actually run into the air, and it did a little bit of GPU, like platform engineering almost, to get it to work. And I thought that was actually pretty neat. All right, John, take it away.
Yeah,
maybe zoom in if you can. I'm not sure.
In the AutoResearch repo. I think it's going all right. Yep, I did mine. Actually, I had some credits to burn in Google Cloud Platform, so I put it on a T4 VM, and Claude gave me some good recommendations on how to make the code adjustments so it was more optimized on the T4, and that's why we trained it on the tiny stories for 5 minutes, and we also had the output pipe to a Firestore database on Google Cloud as well. And I built some reports off of that. I'll show you a few interesting things. Let's see here. Oops. So I'm showing you the Flyte, and a few learnings I had here were failed. I ran out of tokens, so I had to go into Anthropic and do some things. You can see it is up over 3 minutes, and it was only tracking one experiment. And then I made some code changes so that it would actually track the task or show me the task of the experiment that was done in the Flyte workflow. And there can be some further refinements there. So that's why you see the durations go from 334, and then and you see the actual. Let me expand this here. Granularity per task. You'll see the trend of propose, evaluate, propose, and run. Evaluate, propose, and run all the way up and down. So that was an interesting fact. And then let me spend another couple of minutes and I'll show you the reporting. Reporting, very similar to what Sage did. You can see, I'll go to the very first run. This will take about 10 seconds to load. This one had 80 tests. And what you'll see is the first 4 or 5 up to 10. It's trying to figure things out. So it starts with the baseline up above 3, and then right here around this was the 15th. It dropped dramatically. This one only had 30 results actually. This is the one that's currently running right now. You can see the gap between 20 and 25. That's where I had the key. I ran out of tokens and had to go and update my API. So this was on the current run. You see around run 15, it had a dramatic dip. Let me show you the run. This one here, the XO run.
Did it say what it changed for that to cause that big dip?
That one had 80 experiment. Oh wait, no, that's the current one. Sorry.
This is a cool dashboard. I'm not sure. To me, it looks like John might be frozen. So we'll see if he comes back here in a second.
Oh, sorry, I didn't hear you.
Oh, yeah, I think you froze for a minute.
Yeah, the video feed's just frozen, but I hear your voice.
And someone asked, is each dot in the plot
like
5-minute experiment?
Yeah, API calls I'm making to the database are causing my stream to have an issue.
Here, I'll take away your screen. If you want to try exiting out of the API call or something like that, I might improve your stream again. But to answer the question in the chat, so it said, is each dot in there? Oh, now you're back. Oh, yeah, I think it was the request at the same time or something like that. Yeah, so someone asked, so we have a similar chart. Someone asked, is each dot in there a 5-minute experiment?
Let me make the database queries because it obviously didn't like that. Factor that in next time. Yeah, let me share one more time and then I'll give the throne back to you.
Let me try to bring up your screen again.
Oh, there you go. All right, so you're there. So let me. And this chart's a little small. This was the one that had, this was where it was at around 50 runs. And you can see right around the 10th run where it just took, it was 3 successes and then it dove right down. And then it got even further. So, the idea is that the BPB, starts at a baseline, then it runs down, and the model essentially learns the things it has to tweak in order to make it more efficient. So I ran 3 runs. The first one was just running through app.py without any type of Flyte TUI, and then I got curious, installed the Flyte SDK, and started leveraging it through there. And I really like seeing the difference in the data that I got, not only from the effort put into this graph, but also the amount of details I could get from the Flyte SDK pretty easily. So it was fairly straightforward to it was actually more challenging to get the one. I couldn't get a TPU. I couldn't get a T4 in the United States. I had to get it in the Middle East.
Oh,
So it was very, very interesting. That was actually the most painful part of the process was there was no capacity in the United States for one GPU.
wow.
So
this is why NVIDIA stock is so high.
Yeah. So anyways, good project. Thanks.
That's awesome. And all of John's code is also in the same repo, by the way. So if anyone wants to check out his code, again, you can go to the AutoResearch topic in the AI build and learn repo. That is crazy that you can't get. I mean, that's why people go into other clouds too. I mean, because I think you were searching on GCP. That's why I've heard a lot of people look at OCI and stuff too now, because or all these neo clouds like CoreWeave, Nebius, because they have GPU capability. It's just wild that we don't have enough GPUs. But yeah, all of John's code is in here as well. And before I forget, because I forgot to mention before, if you also want to join in the Slack channel, I post a thread for the project every week. And so like, I know me and John were going back and forth and there as we're working on our stuff this week. You don't have to join it if you just want to join the streams. But if you do want to join and be part of the discussion during the week as we're building or like you're building on the project, you can join there and then talk in there as well. But yeah, all of John's code for the project is... Let me get the exact link to share it here too. So this is the one with the T4 is there. So you can check it out. And again, you're welcome to, if you build a project, it could be on your own repo, but if you also want to do a PR into here, that's cool. Or just send me a link and then I'll make sure it's linked from the topic README. Even if it's not actually living in the repo, that's fine. I'll go back to mine real quick. I mean, open up to, again, this is a semi-casual event, so it's really just a fun discussion. What do people think about AutoResearch so far? If you've heard about it, but you never actually looked at it before, what do you think? Was it simpler than you thought? Is it more interesting than you thought? Curious what people's thoughts are on it. Jay, do you have thoughts?
In general, I've been looking for tools that allow me to rely less on cloud resources. I mean, partially for the reason that you just mentioned is that they're becoming more difficult to acquire in the first place because capacity is so limited. But also just, if you're going to leave a looping system like this running overnight to iterate on some toy model or a research project or whatever, like it's going to spend a lot of money if you have it plugged into something that costs anything, even just cents on each request. So I'm looking forward to testing this out with Gemma 4 in the weeks to come. I did some initial tests with that over the last couple days, and it runs fast enough that it wasn't consuming all of my additional RAM left over. So like there's still bandwidth to be doing training on an LLM or some other model. In general, like this setup, I mean, it's a nice encapsulation. The thing that I started to augment it with is adding like a more robust note-taking system, basically, because I feel like in the way it's built by default, you basically it iterates each cycle. It takes the branches or the commits that actually improved something, and it throws away the ones that didn't work. But you're also losing that context. So I started adding like an atomic note-taking system, basically, where it wouldn't actually throw away those notes, even when it had an iteration that didn't have a positive effect. It would write some sort of notes there, compact them so that they don't just completely balloon out overnight over hundreds of iterations, and then not throw that section away, that context, each time it goes to the next iteration of the experiment.
I thought it did pull in. I'd have to double check. I thought it did pull in like basically this file as context. So it does keep. I think it's
TSV.
I think it keeps the high level of what was discarded. I think there's improvement you could do for more context here for sure. But I think it does. Unless I'm wrong, I think it does read in this whole thing as context each time, and it looks at discard. So it does have some knowledge of what was discarded, and hopefully not repeating exactly the same thing over and over again.
Right. Like it's not, I didn't have it necessarily getting stuck in like loops of doing the exact same thing, but I just feel like it's missing larger context, especially if you try to get outside of this realm of just increase BPB for this LLM, each cycle.
Yep.
When I was starting to try and apply this onto an RL training loop, I was trying to find a different metric that I could point it to improve the composite score of how much time the robot or this bipedal humanoid spends still standing, how much actuation it actually had in the motors as it tries to step, and like compositing those different metrics into a single score. I think it was useful for it to have a little bit of higher level context than just, this cycle, I tweaked this one thing and this is what happened. And try to pass that higher level context along. So that was really where I've been trying to improve the general formula.
Cool. Yeah, for me, that the cost to run that T4 would be about $10 a day. So they're around $9 a day. So yeah, I figured for this experiment, I'll close it down and I'll still have credits.
I was running this locally initially with the tiny data set, and I can't remember if it was a Gemma model or a Qwen 4.7, but it was a smaller model because I wanted to save enough bandwidth to still run the training on that same computer. It would start to, at least with using my Mac, it would start to heat up to the point where overnight thermal throttling the CPU, which then changes essentially the capacity of the hardware that you're running the training on. And so it kind of corrupts your results and the feedback loop that it's trying to improve on. So that was an interesting limitation of trying to do everything locally, at least.
What you might be able to, it would add a lot of time, because originally I accidentally was doing this too, was you can, I think you can use load the model into Ollama, do something, unload it, unload it from your thing,
kill the process.
Run the .py, get the metrics back, and then load it back in, and that would add I don't know, extra 5 minutes each time or something like that for loading the model, and probably depending on how big the model is. But you could do it on more limited hardware. It would just be all right, this is literally going to be like a 24-hour run before I get a lot of results, which but could be interesting, right? Like if you're trying to do it that way.
What I started to do, because I was testing this out initially overnight on my an older M2 32 gig MacBook that I have lying around, and so there's not a ton of RAM available on that. 32 is a decent amount, but not when you're trying to run LLMs and train them at the same time. I basically would set it to low performance, so it's not using its full capability, but it also wouldn't overheat, switching back and forth between the training and the inference based on the training. So it was able to more consistently improve performance that way, just by kind of capping how much of the CPU is being used.
And also, that's something to take into account. Just for anyone setting this up, is whatever your hardware you're running it on, 5 minutes might not be enough time to do a cycle too. So keep in mind, if you're trying to play around with this and you're setting up and you're why isn't it working? You might need to adjust the time limit to 10 minutes or even longer, depending on the model that you're using, the hardware that you have. But you could still get, again, potentially meaningful results. If you just I'm going to forget about it for a week and come back to this project. That's kind of a cool thing that you could do with this. And one thing too that I kind of accidentally came by is because originally I set this up on Claude, and I ran 7 iterations on it and was seeing the progress and the value, and then I was switching over to Gemma, and I actually forgot to clear that file, the history file. So then I had the history file basically as context into Gemma. So there might be an interesting thing too, if you want to you could do Claude for some cycles, or every 10 cycles or something like that, so you're not eating up tokens for every single one. So you could be like, how's Gemma doing? All right, now bring in Claude, which is a little bit better. And it's not really a fair comparison.
The
Exactly.
senior researcher.
Exactly. Yeah. You have junior research models. Then you have the senior researcher oversee what they've done. I think there might be something interesting with that, actually,
Yeah.
too.
It's
Because
like, all right, Haiku, Sonnet's going to come in and check progress, and then Opit's going to like direct.
yeah, and it's Claude versus Gemma 4. Gemma 4 is decently small. Also, Claude Code, which is what you're running into, has a lot more of a agent harness around it than just I'm literally running just an open model on this on Ollama. So like Claude does a little bit better, I think, around the thinking and the problem space because of the harness around it too, not just the model behind it. So it's not like a super fair comparison just on model to model basis. But I think that would be interesting. Just like, all right, it runs for hours or however many iterations with something like Gemma. And then, yeah, I like the idea of calling it a senior researcher. Then it can come in and check. But the experiments I ran, just Claude real quick. I only did like the 7 iterations. I didn't do it overnight. Then I was playing around with Gemma. I don't think I put in the table for the Gemma and Claude. This was just Gemma from a clean slate, and then I did overnight. So actually the lowest score I got was with the Gemma one right now, but again, not a fair comparison because I ran it for over 70 iterations, and it just kept doing a whole bunch of different changes overnight last night, which is cool. And actually did end up finding, one thing, if you're using an open model too, is because it doesn't have as good of a thinking harness around it from what I found just in my experimentation yesterday, is I did need to give it a little more context, not like an insane amount. Like I wasn't telling it exactly what to do, but for the overnight run, I actually was like, hey, like be very experimental, try changing all sorts of different parameters and things within the code. And like maybe even listing out some of the stuff. Like I don't think I told it to do depth exactly, but it was like, this might be a parameter you want to look at, because other times when I ran Gemma without kind of the extra context around it, like I don't think it found depth right away on like the Claude run did. So again, if you're using a smaller model without kind of the Claude code or codex type of stuff that makes it run better and thinks better and goes through checklists, you might want to add a little bit more into it, is what I did. But yeah, still experimenting.
My final one was a 1.23, and then I was curious if there was one particular, so total batch size was the major breakthrough one. That was where it got the biggest drop. So I didn't know if you captured that on yours or if it was the same on yours as well.
Oh yeah. Actually, I think it was one of them. If I go to, zoom into my chart here, or I guess I have it all logged here too. But you can kind of tell batch size happened because this down here is the total VRAM used, and you can see there's a big drop, and it actually keeps dropping. And so you can see the big drop happens when it does reduce total batch size for the first time here. And then I know if you look through these logs, there's a couple other ones too that decreases batch size in as well. And I think the big one happened. Yeah, the big drop here. There's a big drop there. Isn't batch size. It's the matrix learning rate is one, and then yeah, some other parameter changes. The big one down, I guess, would be down here, right? So this was, I think that's the learning rate was the big change here for me.
Interesting.
Yeah, it's fun seeing this chart go down, and mine's still progressing. It gets a lot slower here, but it's still going, and found a couple other keeps, I think, since I had made that chart render of it. And Chris said, best to have a server running locally to offload the compute locally, but obviously expensive. Yeah. Yeah. But maybe less expensive than burning all the tokens over time if you're actually seriously doing something with it.
My son has a new gaming PC. I probably could have taken that from him. Made him real happy.
But one thing I had mentioned at the beginning that I haven't done yet, but I think would be fun to do is do experimentations in parallel. Although this would require you getting either fitting them into the same GPU or
Mm-hmm.
getting 2 T4s in the US instead of 1. But then you could do like this again, could become a lot faster, I guess, per experimentation. So you like do, if you could do like 4 at a time, get the results, discard, keep, and then put them in one log, and then figure out and then go to the next step and do like 4 at a time. I think that would be kind of a cool thing to do. I haven't seen, I'm sure someone's done it. I haven't seen an example of it done specifically with like AutoResearch.
Right, it's a similar idea to like generate multiple different prompt responses and then move forward with the one that performed best.
Yeah.
Yeah.
And someone said, doesn't everyone have an RTX 6000 Pro? I don't. Do you? I assume you do.
It was like $4,000. That was over now.
Which also, Giuseppe, I think you're supposed to post about your cool robot in the Slack too last week. I'm still waiting for the robot update. Yeah, any thoughts from anyone watching on the chat too? If I don't know, on AutoResearch concept, like I was saying, I think it's fun to, it's something I had heard about and I had to actually like run it or implemented it. And then it was simpler than I guess I thought it would be. And turns out it's actually similar to stuff I've already done in the past sometimes too, like building a loop. You're building a loop. It's basically an agent. You have an LM looking at something with a loop. There was I saw a tweet or something like that I thought was really funny this morning. That was something like says like, Karpathy, like I put peanut butter and jelly on toast. I really liked it. I'm gonna call it peanut butter jelly sandwich. And then it was like GitHub stars 150,000 or something. And again, the
RTX is 90. The RTX is $9,300. So there you go.
Oh, the RTX 6000.
Damn.
Yeah, 9349.
Yeah, I don't think I'm going to be acquiring a GPU anytime soon with the crunch right now. What I do have is 2 Macs sitting at home. So I think probably the next step for me would be to set up the extra one as a server, so that at least on the local network, or pass it through like an IP proxy, so that I can just point the laptop that I'm actually running a local LLM on, or running a cloud model from, and doing the inference on those training cycles, and just having the training happening on that separate Mac.
What's the chipset on those, if you remember?
On the Mac?
Yeah, like what like both of them?
It's the M2 Pro for the 16-inch older one. So I think it has like 19 GPU cores and 12 CPU cores. It's not crazy. The newer one that I have is a Max. That one has like 40 GPU cores and 64 gigs of RAM. So it's a little bit more capable of running some of the more reasonable local LLMs.
Cool.
Kind of why I got it.
Christopher Riviere in the chat called you a smart man. So you're on the right path.
I mean, I'm just hesitant about, like, I was running a game server over the last year on Google Cloud, and it took forever just to knock out the entire VM instance. Not like the server was running in the background for a while. I took that down, but I kept getting these $5 charges. And it took a while just to figure out where specifically that was coming from. It was like
like storage or something like that.
Yeah, it was some leftover like memory cache that I didn't realize had been attached to the main process. So I'm just hesitant about like leaving cloud instances running for long periods of time.
I know I've done that a long time ago, where with an AWS thing where, you know, it was like $1 a month or something like that.
Yeah,
but for like years.
I'm like, it's not annoying enough for me to actually deal with it right now, but I'm hesitant to leave a looping process just running like that.
Someone had asked a good question, and this is for everyone watching too. If you want to answer in the chat, again, if you want to come on the stream, send me a message as well. It's fun having more people up here. But how does AutoResearch fit into the bigger picture of AI? So it's a good question to think about, even if you're not up here and you want to answer, like give an answer in the chat as well. I think the idea here, this is a pretty simple case, but I mean, I wouldn't be surprised, right, if some of the larger research labs are in theory doing something like this on their actual LMs or products. So if you actually get good results with something like this, if you can run it just, somewhat infinitely or however long you think it is to run experiments and maybe find stuff that you as a human didn't even think about. If there's, a ton of different parameters and stuff to tweak in there, then over time, like the overhyping part of this is that you could have, Claude or something like that, use this and just infinitely self-improve over time. That's obviously probably not exactly really the case there, but that's how we're going to get to AGI. It was
somebody's going to plug Mythos into this and then it's just going to take off.
But I think there's a lot of cool smaller use cases for it too, actually. Like you can have optimization on your models or something like that running. There's been some use cases where I've wanted to build starter projects or something like that I don't have time to start yet, and I'd love to just give like a list of those projects to something like this and have it iterate over them, and then have a good starting point for me to actually come and grab that code once it reaches to like a certain validation metric.
Yeah, looks like somebody said Karpathy himself said AutoResearch will help scale up research efforts in all major labs much faster. I feel like the general improvement here is that it's a clearly packaged approach to take a research problem, assign a really simple metric to it that a machine, an LLM can look at and say, oh, it got better or it got worse, and then iterate and try to improve it. And that's a mental model that can be turned into a programmatic loop, which then all these different teams, or just, we sitting here in the afternoon after work being like, I have an idea and maybe I'll just try to plug in this particular model or problem and figure out a specific metric I can measure it off of and let it run overnight. And like, I wouldn't have time to do that otherwise, but I can just spit out a few different variations of that over the course of the week in spare time and have it running in the background. And then maybe one of those models is actually worth digging into a little bit more and like putting some more, concerted effort into it.
Yeah. And I think even longer time periods too, like I was saying, you could do this over a week on something that you just don't have time for, and then come back to it on the weekend. Like maybe start something on Saturday. Like if you have a side project and you're like, I'm going to start this on Saturday, and then I won't be able to get to it again until Saturday. And you can come back and see a list of experimentations that you wanted to do, but you just don't have time to run through yourself. You get all that logged, hopefully, and maybe interesting things that you didn't think of either. And I think Christopher has a good point. This has always been true with any AI problem, but well before LLMs as well. It's just data quality. And so they said, I think the biggest piece being overlooked is feeding quality data to feed these models for better quality outputs. But it could be wrong. Yeah, instead of just like if you're doing auto research here, I'd imagine that in a lot of these cases, without being able to feed it better data, I don't know, I'm not a LM researcher or anything either, but this is going to probably do some marginal improvements, but without having something really crazy breakthrough in the architecture, which I guess, again, in theory, it's like, if this could come up with that, that'd be awesome. But realistically, is it? I'm not so sure, at least, in the current state of LMs. But yeah, to have a bigger breakthrough or better models, sometimes that's getting data quality in. But maybe you could have like, if you wanted to, you could build a loop where you could have an LM also try to, like if you're optimizing a smaller model and you're doing something like GRPO or some sort of reinforcement learning on there, you could have a larger LM maybe even do like labeling of data, auto labeling data. Maybe that's even coming in from somewhere. I think that's actually a pretty interesting use case. And maybe instead of research, it's auto train, which again has been around in various forms for quite some time. But you could have live data coming in from something. You have something that's like an LM as a judge, and then you train a model on it. And maybe part of that training isn't just training the data, but it's adjusting the hyperparameters like AutoResearch is doing. And then you could like auto deploy that and do A/B testing and then just see when a model is better live in production. I think that would be interesting too, instead of like again, auto ML has been around for a long time, so it's kind of a form of that, but you're just kind of redoing it in a different way that might be able to add, like, be a little bit more dynamic than what we've had in the past with auto ML.
Was it? Apologies. 40 metrics of improvement using AutoResearch. I feel like the reason that this one works relatively well is because the scope is super limited.
Yeah.
And as soon like I ran it through with tiny stories, and I was like, oh, okay, it's actually like able to incrementally improve. I wasn't getting 100 cycles overnight, but I was getting, like 30, 40, 50, and maybe a quarter or a fifth of them actually made some sort of marginal improvement. But if when I started telling it, all right, let's actually try and let's open up the space of things that you can change to make improvements. Let's start thinking about maybe we'll do a little bit of a different architecture, change the way that the model is actually implemented. It very quickly spins off and just starts circling and waffling in areas that aren't really helping, and it would continuously make regressions in the model and just throw all of those away. And essentially it's just the focus on val BBB and the narrowness of this problem that makes it work well. I feel like the models that we have generally still aren't doing a very good job at just like broadly generalizing and saying, okay, how do I just iteratively, improve the model, make it much better, and then just go crazy.
Yeah, I even had kind of a note in there that's like one of the biggest takeaways from this, instead of just you using Cloud Code to say like do whatever, is that this is really fundamentally is a really clean way of just binding the agent to do something useful in a closed loop.
Like very, very narrowly focused problem. That's I think the success here.
Yeah, I totally agree. Yeah, and it's like you're basically just adding a ton of constraints in here. Like there's one file that you edit. Don't go mess with a whole bunch of other files or think about those things.
It's easy to see if it started going off on the rails and doing a different thing, or trying to mess around with a different part of the program. You're like, let's stay focused right here.
Yeah,
it's the only thing.
Yeah, so it's super cool. It's fun. Like I said, I've done it was something like somewhat a little bit of akin to this, but I like maybe the narrow scope that this has that mine didn't have. But yeah, I mean, LLM in a loop doing something is what this is, just with a lot of constraints and a well packaged and easy to get started. Like I think that's a big thing too. Is like this is like clean design to get started, and has Karpathy behind it, which is awesome. So draws a lot of people in. But I think it's a cool thing. Curious if anyone is going to go play with it now that you've heard about it on the stream, because I see quite a few people watching. And someone had said, apologies, 40 metrics of improvement. I don't remember what that was too. It totally might have tied into the conversation, and now I don't remember what exactly that was going to be. And then Chris said, true, he tried QDT on Gemma 430 or Gemma 434B using Opus as a teacher model, but needed hundreds of thousands of teacher outputs for successful distillation. The quality improved, but you were getting getting incomplete outputs from Gemma after doing that. I think is. Oh, and I think were you saying Gemma 4B, not 34B? So the smaller condensed version, and then fine tuning it with something like this, getting kind of like I was saying, getting distilled outputs. Except for in my use case, I was saying like working live data using LM to then label it. But yeah, you can get distilled output or get outputs from something like Claude and then fine tune a model on it. You could do something like that with AutoResearch. I mean, it sounds like Christopher is working on awesome stuff. So I really like his takes. Do you have a local GPU, Christopher? You've mentioned it several times that's how you would set up, but I'm not sure if you have that set up right now. And if so, I'm curious what it is. Oh, there's
Uh-oh.
some spam link, maybe. I'm not sure. using AutoResearch, so not a spam link. I don't know. The link didn't show up because YouTube might have thought it was spam. So if it was a relevant link for the 40 improvements, I'm not sure. Shopify does cool engineering stuff too. Okay, and Christopher says they've been running Blackwell server for prototyping. Awesome. Yeah. Oh, I think at the beginning you were the one saying the Blackwell errors are annoying, right? It's funny too, because even with just using Claude Code to run stuff on there sometimes, and it was trained before CUDA 13 came out, and sometimes it's like very adamant CUDA 13 doesn't exist, and I have to be like, no, here's the install like command for the
here's
Python
the docs page.
it's like PyTorch doesn't exist for CUDA 13. It's not out. Like, it's been adamant sometimes, like, no, it's out, and it's like, no, it's not. And then I have to be like, here's PyTorch. Like, this is the version for it, which I just think is pretty funny. It's like, yeah, when you're on the cutting edge hardware, the LMs struggle sometimes. But I was impressed. Like I had mentioned, I think I even had the log still. That the first part of my Claude experiment was actually it, like, updating and installing the right stuff to run on Blackwell, which was, I was impressed that Claude was able to get it work in AutoResearch, because I was having problems with it in the past with Claude Code. So I thought that was kind of cool seeing it actually do, I don't know, like the hardware, the platform side of it, getting it working before it could even run the experiments. And I thought that was actually cool. Yeah, Chris said it's so annoying sometimes. Yeah, it's like, well, it reminds me, it's still a little less annoying, I guess, than installing CUDA like 8 years ago. Like I remember having so many issues sometimes getting like PyTorch to run, getting the right CUDA environment set up on your GPU, on your gaming PC and stuff like that. So I will say we've come a long way of ease of use, which is great. So it said, what is the underlying mechanism to identify present contradictory findings? So like right now, all it does in the default AutoResearch. So if you're setting it up, you would come up with your own validation metric. But all this one really does is it like I said, I don't have it here, but all it does is it compares this value, and if it lowers, then it keeps the change. If it went higher, then it reverts, or then it will discard that update. So it would be up to you, like, for if you're implementing this on your own thing, what is that validation metric that you would want to use? Any other thoughts on AutoResearch from people on stream or in the chat? I'll share out a link too for next week's stream if you want to join in.
I did find.
I'm curious, Jay, if you're running it locally on your Mac, is it like constantly? Is the fan constantly going? Is it overheating or anything, or is it?
That's what I was initially having issues with. It's just cycling between the like Ollama and the local model running inference, and thinking essentially through the results from the last time, and then deciding what to augment, making changes, and then switching back to training that are doing that 5-minute training cycle. I basically, at least on my 32 gig M2, I had to put it on low power mode so that it wouldn't just constantly overheat and then throttle itself. And that way, at least the performance was consistent.
And what about you, Sage, running it locally?
I'm running it on the DGX Spark, so I remote into it from my Mac, so my Mac wasn't spinning any fans. Right. The DGX, I think it has a fan. I went and I touched it one of the days, and it was warm, but not as hot as it has been. So it wasn't pushing it to its limits like some of the other models I've run on there.
I think it has a fan.
Where does it actually start to tap out? At least as far as like running LLMs, like larger. I don't know. Can you run like a 70B or larger model on there and actually have a reasonable token per second inference speed?
I forget which. I have to look at the largest one I ran. It was the Quinn Coder. I forget if it was a 70B though. I think if it was probably a quantized coming in there. Otherwise, I think I've run like the 31B runs fine. I think it's like half of the memory or something.
Yeah. But like the speed, I guess, is usable at that point for some of these.
Yeah. For stuff I'm doing with it, I know one thing with the Grace Blackwell or the DGX is sometimes the inference speed is a little less than actually some of the other consumer GPUs you might get. Like, so you start seeing tokens, maybe not quite as fast, but they're fine for what I've been doing, or for something like this, right? Like it still seems pretty fast to me. I'm not trying to optimize as like a consumer product or something like that where I need the lowest latency possible.
Right.
I just
and they're like faster than you can read, then you're probably good.
Yeah, or it's just like I need it to do a thing and it's totally fine for that. Technically, something else might be faster. But it's been good because the big thing is just getting the 128 gigs of memory that you can load big stuff into.
Right.
And Christopher said their MacBook fans are always screaming.
The fans are definitely on when I'm using them for this case. But
and also said knowing ML fundamentals would help a ton. I'm not sure which that was probably referring to some question at some point as well. Forget or another question in the chat maybe I missed. But I think maybe it was responding back to what is the underlying mechanism to identify. Or when I was talking about it's up to you to come up for that evaluation metric for your model.
Yeah, that was a bit of a process, and I'm still sort of iterating to figure this out for RL training iterations. One is just figuring out, like, I'm trying to build more of an understanding of RL. So, what is the equivalent of taking a 5-minute slice of training and then measuring BPB for an LLM, but for training a bipedal robot to actually be able to walk successfully.
Yeah, that would be, by default, it's like the reward, but
right.
But I think we have talked before about sometimes the model still will get a high reward, but it walks really weird. Like you have to define really, really good reinforcement learning policies, because otherwise, like if the reward policy is just get the bipedal robot to the other side of the screen and that's all you're really rewarding, then it might be like bouncing on its head to get there. If you don't have the policy also being like, you have to be standing upright. Like, so you have to add in stuff like that, or specific joint movements. Like it might walk really weird and you're like, well, no, actually now I need to add in reward as like the proper gait or something like that. Right. So like that'll probably be just like a big iterative process before you even get to the point of needing the auto research, at least from what I found, because a lot of times like visually looking at something for how like a robot walks is how like you can be like, that's off, I need to adjust the reward policy.
Right. I can actually, I found the first RL results that I was going through on this.
I'll bring up your screen.
Yeah. So like you can see, and I think this is all running through Mujoko or Mujoko. And so like visually, I'm getting results like that, where it's not even capable of taking a step. And then after about, I think I switched over to this humanoid after a couple rounds, and then got like 20 more cycles in, and it's basically twerking before it actually, hold on, 26. That was the best one. It's like just doing some crazy movements for a few seconds before it gets stuck upside down in the space. But the general training cycle was looking at this and thinking, oh, this is marginally improving, but I need to do some tweaking on the actual reward metric that it's trying to measure that improvement on, because clearly it's not getting better in the right way.
Yeah, one thing too, I don't know how it break this down for the auto research, but is you can do it's called curriculum learning, I believe. So you give it a task like to do something simple first. So actually this might work good for auto research. Maybe it's like you say, first, I want the robot to stand, and you get so many iterations to make that happen. And so you give it like a simpler task before you say do something else. So it's like incremental, like teach us to stand. And that's the only reward policy basically. And then once you have that, then you say take walk or take first steps or whatever. And then you keep adding these things and incrementally on it. So instead of just saying like, here's a reward, go at it. You say first optimize this reward. And then now that you kind of know that reward a little bit for how to stand, now we're going to add another one, and that's going to be like moving forward or something.
So just like you kind of decomposing the problem space a little bit to just stay upright, like balance and stay on your feet. And once it learns to do that, then adding a separate task, which is taking steps and moving forward. I wonder if that would work good for an AutoResearch type of thing instead of just saying like, go, here's one policy, go at it.
Yeah, just start stepping.
Well, we're at the hour mark. I know I have some other stuff I got to finish up today for work before it's the weekend. John just said goodbye. Well, he didn't say goodbye, he just left. Goodbye, John. Thank you everyone for coming in. Really fun talking to everyone in the chat. Christopher, everyone else who was talking, super fun. Thank you. If you want to join in next time too, feel free to message me. It's fun it was really fun having John's been coming up here. It's really cool. Jay, awesome to have you here. If you ever want to come up again, talk about whatever projects are. Christopher said, cool pod. Great job, guys. Thank you. Yeah. And again, this is like super kind of a casual stream where, you know, I'm not always going to be an expert in the topic of the week because I'm going to also be playing around with it. And sometimes they're super new, like the Gemma 4 model just came out. I haven't done a ton with it. That's next week's topic. I'm going to play around with it next week and then talk about it up here. So hopefully this is fun. And if you like doing that, you're welcome to come up and talk about it. And then also, like I mentioned, you can join the Slack channel, talk there during the week. You can do an intro there as well. And hopefully I will see some of you on the next stream or in the Slack channel somewhere else. So thank you, everyone. Thank you, Jay.
Thanks, Sage.